Okay, so let's wrap up kind of what we've seen, not just a summary of the topics, but kind of let's take a step backwards or upwards or adventure words and think about some of the implications. So kind of the big picture of what we saw, we've seen a lot of technology buzzwords, right, and a lot of different protocols and technologies. We talked, but really you can kind of tie all of them back to this model view controller architecture. The controller, the thing that deals with user actions, well, we saw that URIs are the way that actions are expressed. HTTP is the way that communication happens between the client and the server. It depends on TCP/IP, a venerable set of protocols that lets us pretend we're just exchanging strings. And that having RESTful actions and RESTful routes is a nice structuring mechanism, especially for making your app friendly to interoperating in service-oriented environments. Views, we saw that the most common way to express them was with HTML and using CSS for styling. We didn't talk about XML and XPath because there wasn't going to be time in lecture, but I'm going to find a time to get that topic in, especially XPath, which is like the regular expressions of the XML world. And then for models, we talked about databases. We'll talk about migrations next time, which is how you make changes when you want to add a new kind of thing to your app. How do you change the database to do that? And we talked about CRUD, which are sort of the 4 basic operations on persistent models that any app has to know how to do. So let's talk about a couple of fallacies and pitfalls that, with the benefit of our background.
One thing you forgot to mention is administrators get tests next Tuesday.
Okay, let me I'll pause in the recording. I should have said in the administrivia, don't forget that there is a quiz next Tuesday for the first 30 minutes. So that means starting at 11:10, going till 11:40, not starting at when people get here till 30 minutes after that. And that means that Monday's section would be an excellent time to ask questions about anything up to this point. The quiz will cover everything up to the end of today, but obviously it won't cover the stuff that we're going to do after the quiz on Tuesday. That'd be rude. And it'll generally be sort of short answer and multiple choice kind of questions. So you're not going to have to like write out a lot of stuff. You will not be writing limited in terms of finishing the quiz. Closed book, closed notes, closed everything. But believe me, if you've been keeping up with lectures and doing some of the readings, shouldn't be a problem. Yeah. It will, if it includes any coding if it includes any coding if it includes coding, it'll be like filling in a blank. Like maybe writing a line of code. Right? It's a quiz, not programming. The coding is, we're saving more of that for the homeworks and the project. Okay. Audio pause. In 2008, there was a sort of meme circulating about how Rails doesn't scale. And part of it came from the fact that Twitter was having a number of problems with availability. Twitter was built on Rails. It was kind of one of the poster children for, Rails as this productive framework. But I think as we've now seen, and you guys now understand, scalability is not a matter of which language or framework you use. It's an architectural concern. And in fact, the stateless tiers of the 3-tier architecture scale really well, especially with cloud computing. You just have to worry about, how many machines do we need? Is it a matter of 10 or 20 machines for a given number of users? But that's really a matter of efficiency. What we did see, though, is that relational databases really don't scale. And as a result, there's been a number of solutions that combine relational with non-relational storage. If you've seen the term NoSQL, NoSQL has become this catch-all term for relational databases are terrible because they don't scale. We're going to start everything over again. And never mind the fact that, for 40 years, relational databases have solved all these important problems. We can do better because we're Web 2.0. As it turns out, the truth lies somewhere in between, and most large sites use a combination of relational or SQL databases and non-relational storage. As we mentioned, Data Mapper is a way that you can impose some order on how your storage works, even if you're not using a relational database. But the idea of scalability is much more complex than just saying, oh, your language or your framework doesn't scale. Frameworks, apps, and design patterns. We've already seen a number of examples of different design patterns. But keep in mind that in 1995 or so, when the web was just getting big, it was like the Wild West. The biggest software sites, the biggest SaaS sites at that time ran on mini computers. They didn't run on the cloud. The 3-tier architecture wasn't really a thing. And the idea is that as more people built more sites, they sort of extracted patterns from their experience. And they tried to capture those patterns in useful frameworks like Rails. In fact, Rails itself didn't start out life as a framework. It started out as an application, and Rails was extracted from the application because it was believed that it would capture a lot of common stuff. Despite all that evolution, I think it's admirable that we have TCP/IP suite from 1969, a markup language based on 60s technology, browsers still around that were released in the 90s, and web servers like Apache that have been around since about 1992. And in 2011, these things can all work together. So the power of APIs and well-defined protocols, right? This is longevity. This is long-lived or long-lasting software. Just to recap some of the examples of patterns that we've seen, along with some alternatives. Client-server is how SaaS apps tend to be structured on the web, but peer-to-peer is another way to do it. We talked about the shared nothing model with cloud computing, but until the mid-90s, much more common was symmetric multiprocessor, where it's like one large machine. Model view controller is a way of organizing the entities that your app manipulates, but we also saw that page controller and front controller are other ways to organize apps that maybe for simpler apps could be more appropriate. Active record is one way to map the models back and forth between the database, but it takes advantage of some database features that might impede scalability. So some people prefer data mapper if they are able to structure their app in those terms. And the idea that we can create services whose operations are RESTful and whose URIs encapsulate all the information you need to do the request is, in my opinion, a strictly better pattern than the sort of anti-pattern of the same URI can do different things depending on what you did previously and what the phase of the moon is. So kind of my big message is, as you work on other apps outside this course and in real life, you should always find yourself asking, what are the architectural alternatives? What's the choice we didn't make? And are we sure that that was the right thing to do? So having said that, we're going to spend the rest of the course doing model view controller the way that you guys have seen it. But I thought it would be I would be remiss in not giving you guys a little bit of perspective. So, to summarize, model view controller is a well-known architectural pattern for organizing SaaS applications. Rails codifies this structure as model view controller and gives you a lot of help in terms of sticking to the structure. For views, we're going to use HAML with embedded Ruby code. For models, we're going to use a relational database with active record. And for controllers that tie them together, it's just simple Ruby code that is tied via routes to the outside world. This is the view of the world you're going to have, but the goal of today was to show that other views of the world are possible.